Hi guys, I'm going to be adding a link to this code on GitHub, a repository on GitHub, so just make sure you clone it and go ahead to install the dependencies by running yarn. You'll find it here in the README. So just run yarn and install the dependencies. Okay, so we're going to start by doing the data indexing or the data preprocessing. So this is where we have to deal with the load, the split, the embed, and the store of the data like we talked about earlier. We'll make use of Langchain, and from Langchain we'll be using the recursive character test splitter. And we're also going to read the file using read file sync from Node.js. Okay, so we read the file, which is the gimfax.txt, this document here. Then we use the recursive character test splitter class. We initialize it. Just in case you are confused about anything from the Langchain library, just copy the class and go to your browser and type in Langchain.js and paste whatever it is you want to search for, and then you so here we have test splitters Langchain. This is already Langchain.js, as you can see here. So when you get down here, you will see a sample implementation of the recursive character test splitter class. Now it takes different arguments. It takes the chunk size, which would normally be 1000, and a chunk overlap, which would normally be 200, except you change it by yourself, you specify it yourself. So what is chunk size? Chunk size just means how many characters will be in a chunk, in a split chunk. And chunk overlap means how many characters will spill over into or between between chunks. So using this sentence in the example, say you want to split this and you have a chunk size of 10 and chunk overlap of 1. So that's very specific. So let's say this is 10 characters. I won't be able to count now. So this is chunk 1. The next chunk would contain the last one character in chunk 1, and then it goes up to 10 characters. The next one would pick the last one character. So whatever is specified as chunk overlap, if you specify it to be 5, 10, 15, 20, that is how it's going to pick the last 10, 15, 20 characters from the previous chunk and spill it over into the new chunk. So from here, if E was the last character in the last chunk, it picks it up again because we said 1, so it just picks up that 1 character, and then it goes on to 10 characters to create the next chunk. If chunk overlap was 5, and let's say these are the last 5 characters of a particular chunk, to get into the new chunk, it picks these last 5 characters and then it goes over into the next chunk. So that's what chunk size and chunk overlap means. So to run this code, we open the terminal, then we use Node.js to run it. Remember, it's inside the utils folder, and the name of the file, split document.js. Run it. So let's see from the beginning. Take this up a little. So it says getting started. I'm just going to open the document that we are trying to split. This is the document we are splitting here. And it says getting started. We have a new line. So it separates this and goes on to the next. It says, do I need to be a member to use the gym? And there is a new line again. So we have a new line. So this will be serve as a separator, and then it goes on to say, yes, our gym, blah 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 blah. As you can already see, if you count this, all the characters in this particular chunk, you'll probably get 500 characters or 400 and something. So it must not be exactly 500, because remember we are trying to consider the separators. So if, for instance, this is 490 characters, it's not going to include the next 10 characters to make it exactly 500, because the next 10 characters will be incomplete, like an incomplete sentence. Okay, so it will just try to maintain something reasonable below 500 characters. So that is it. And as we can see, this likely has maybe, so if you see that your chunk has too many information in it, you can also reduce the chunk size by making it, say, 300 or 400. Remember we used 500. Okay, so looking at this response, or this output that we have, it's an array containing different document objects, and then each document contains the page content and the metadata. You can print this metadata to see what it means. So let's just go back quickly and do output, select the first output, and then get the metadata. Okay, let's run this again. So this is what metadata looks like, and this is metadata for the first document. So it says from 1 to 9. This is from lines 1 to 9. When we go to the document, we'll see 1 to 9. What if I'm new to exercise? This is line 9. So when we go back to the document that is in the first chunk, we actually get from line 1 to 9. So this is very easy to understand, hopefully. Let's see what happens when we reduce the chunk size to, say, 400. We don't want it to be too small. And let's see what happens when we make the chunk overlap to be, say, 20. Oh, about chunk overlap, yeah, I was going to explain that. So the chunk overlap, as you can see, the last characters, the last few characters we have here says, what if I'm new to exercise? And you see it spill over into the next chunk, which is what we have here. What if I'm new to exercise? And I think that's fine. We should just leave it at 50. Let's not reduce it to 20. 50 is fine. Yeah, so let's see 400 and see what output we'll get. Okay, let's go up. Yeah, so this is what we have now. The what if I'm new to exercise is no longer in the first chunk, because now we have 400 characters in the first chunk. Okay, so this is it. You just have to play around with it and see what suits your use case. So I just copied the code snippet for embedding the text that we just split, and also storing them in the database. So we are going to be working with Supabase, like I said. And before we start talking about the code, we're just going to go to the Supabase platform and create our database. So go over to the README, initialize. The second step says initialize your Supabase database by following the instruction in the docs. So we're just going to copy this and we go to our browser. Let's see. So it says go to the SQL editor. You click on this. It's going to take you to Supabase dashboard, and if you haven't created an account, you create an account. And going back, follow the instruction. It says click the Langchain in the quick start section, click run. I'll just quickly use my personal account to explain this, and then we'll click on new project, the same organization, project name. Now we say chat assist. Then you select your region. I'm going to select London, because in London, is there in London? No. Oh, there's a London here. So select London, create new project. So you're just going to pick two things, which is the public key. So you copy this public key, and you also come down here and copy the project URL. That is all you need to access this particular database. Our .env file, which contains our environment variables, go to the SQL editor page in the dashboard. So come here. Oh, SQL editor, not table editor. Then we click on quick start and we select the Langchain quick start. So this already has a query for you to run to create the database. To create the table. So the name of the table will be document, and we'll have a function called match function that we'll be using to do our similarity search. Table is going to be having the ID, the content, the metadata, and the embeddings. So we'll just come here and click on run. And then it says success, no rows returned, because we don't have any rows yet. So we'll come to table editor and we have the new table we just created, which is called documents. And we have the ID, the content, metadata, embedding. So we'll come back here once we feed our document into this table. We'll come back and see that the table will contain the different chunks that we have. We get the create client method from Supabase. We get the Supabase vector store class. We also get the OpenAI embedding class from OpenAI. Okay, so remember to get your OpenAI API key. Also add that to your environment variable. So let's just go down to this section. So this is where we load the environment variables. And now we initialize OpenAI embeddings. To get embeddings, add your OpenAI key. Then we create a Supabase client, also using the Supabase URL and the Supabase API key that we just copied. Okay, now it's time to save this document in our database. So we need to get the output which we had earlier. So after embedding the document chunks, we pass it into the next argument. So the next argument will take the Supabase client, the name of the document, the name of the table which we just created on Supabase. Remember, the name of the table is documents. Then a query name, which we'll be using to query the database. All right, so once that works, we print success, and that is it. So just going to come back here and run the same file again with Node.js. Give it some seconds, then it says success. Okay, that is it. So let's go back to our database and see what we have on our table now. I'm going to refresh this. This is what we have. We have the content. This is like the human readable content. Getting started, blah, 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 blah. What if I'm new to exercise, membership option. If you expand this, you likely see like everything in this chunk. Then the metadata, we already talked about this, from line 1 to line 9, 9 to 14, 15 to 26. Then we have the embeddings, which is our main focus here. So this is what the embeddings look like. All right, so that is it for setting up the database and creating the document table. So now that we're done with the document splitting, the next thing that we'll do is to go ahead and build the chatbot. So we are going to be working with HTML, CSS, and JavaScript. This is going to be vanilla JavaScript. But because we are going to be working with some node modules, we'll be using a bundler called vit.js. So if you go to the package.json, you'll see that we have Vit installed alongside all the dependencies that we'll be using. And this is mostly from Langchain. We'll be using .env to load the environment variables. Okay, and then we have Supabase as well. Now, when you go to the README, you'll get instructions on everything that you need to set up. So let's start with the HTML file. This is a basic HTML file that has, everything, the head, the body, and then it contains the different sections. Then the next is the CSS. This is the CSS file containing all the styles that we have for the HTML element. And then we go into the main.js file. This is the file that contains the logic for our chatbots. It makes use of some functions that we have defined in the utils folder. Up here, we've imported all the libraries that we need, and all of them are from Langchain, except the last two, which is the custom functions that we created. So we have OpenAI language model, large language model, which is the model that we'll be using to do our generation. We have the prompt template. We have runnable sequence. There's no need of explaining what all these things are until we get to the implementation. Up here, we have an event listener that we've added so that when the user submits the form and clicks, we run the conversation function. So I'm going to just quickly run this to show you what it looks like on the front end. Yarn dev, enter, and we open this on the browser. Open this link on the browser. So this is the form that takes the user input, and this is the submit button. So the event listener listens for when this submit button is clicked, and then it calls the run conversation function, which is somewhere down in this file. Just going to put this down and scroll down to the end of the file. So we have the run conversation function here. We'll talk more about that. We have a runnable sequence class instance here. We have our OpenAI API key. Make sure you copy this API key. Just go to OpenAI documentation. Well, I'm going to talk about this now, but I just wanted to show you, this is where you get your OpenAI API keys. Now, this is talking about usage, like how much you've spent so far on your application. And to tell you, this is actually what I've spent so far while building this project, both from setting it up to preparing to do this video recording, and up to now that I'm doing this video recording. This is what I have spent so far. And if you hover over this, you will see that ChatGPT-4 is actually way more expensive than every other thing here. We are using three models. We are using the ChatGPT 3.5 model, and which is a chat generation model. Then we are using the embedding models, which we used to create the embeddings. Then we have the GPT-4 model, which is also a chat model, and it's actually currently the most expensive. And the good thing is the latest available model from OpenAI. So if you feel that this is too expensive for you, you can just stick to using the GPT 3.5. But I can assure you that you will not use up to $1 for this project. I think the minimum you can add is $5. So just have some money in your account. Now, about this import.meta.env is the process.env version for Vite. So rather than using process.env, we're going to be using import.meta.env. You can find that in the Vite documentation, which I have dropped in the README file. Scroll down here. You have Vite.js documentation. You have Langchain JS documentation. Up next is the chat memory. Now, we want to be able to save our chat so that we can have a history of the conversation that we have with the user. We want to save the user question and the answer that the chatbot is giving to the user. So those are the two things that we are saving in the memory. So the input is the user question. The output is the generated answer for the user. Return messages, you have to specify this because you are using a chat model, and that's it. So the memory key, like it's a chat history. Up next, we're going to be creating two prompt templates, one for generating questions and one for answering questions. By the way, a good percentage of what we have, the code we have in this file, you can actually find it in the Langchain documentation. So when we go to come here, just Langchain JS chatbot docs. So this is where you'll find the documentation for this particular file. And the whole idea is that it's a chatbot that has a memory. So I'm just going to show you here. Go to Langchain conversation retrieval QA. So this is what we want to work with. It's just going to scroll down to the built-in memory part. Yeah, so this is the built-in memory part. And we got, so this is where I got my inspiration from here. And this is very legal. Like, I'm not doing anything wrong. I'm not committing a crime. It's okay to copy and paste as long as you understand what you copied, as long as you're able to edit it to suit your use case, as long as you're able to explain it to another person. There's absolutely nothing wrong with copying. I mean, if you're using the library, you're already copying them. All right, so let's go. So we copied this for creating the memory, and so this particular code snippet is written in TypeScript. If you scroll down here, you will see that it's written in TypeScript because there are typings here. But we are working with JavaScript, so we will not be using like everything line for line, okay? So this is what we are working with. We have the user we ask the question, and then we pick up the user question, add a prompt prefix, and the conversation history if there is any. So the first time the user is chatting, there is no conversation history. So with that, we're able to generate the question prompt, and that's the standalone question prompt. So going back here to the code, we have the standalone question prompt. We are creating it by calling prompt template.fromTemplate. Prompt template is gotten from Langchain, and it's a schema to represent a basic prompt for an LLM, large language model. Okay, so we have the prefix which says given the following chat history if any, and the follow-up question. Rephrase the follow-up question to be a standalone question. So we are passing in the chat history, we're passing in the user question, and we want to generate a standalone question. A standalone question is, I don't know how to define it, but I see it as a question that is more tailored to the context that we are working with. Okay, and also if the user question is like really long with lots of information that are not like necessary. I mean, people can type long sentences just to ask about a simple thing. Then the standalone question prompt, we generate a simpler question for the user. Then the next prompt we have is the answer prompt. So let's go back to the slide. So the answer prompt is what we have here. So with this answer prompt, we'll be able to generate a suitable response for the user. So it will take a prompt prefix, it will take the user question, add the nearest match, which is the match that we found in the database. We also add the conversation history, and with that, we'll be able to generate a suitable response for the user. So that is what we have here for the answer prompt. So the prefix says you are a helpful and enthusiastic support bot who can answer a given question about a fitness company based on the contents provided by the chat history. Try to find the answer in the context. If the answer is not given in the context, find the answer in the chat history if possible. If you really don't know the answer, say, I'm sorry, I don't know the answer to that. And direct the user to email awesomegym@sample.com. Do not try to make up an answer. Always speak as if you were chatting with a friend, and you do not need to tell them where you got your response from. Okay. So this prefix, you can actually change it and make it whatever you want. If you are building a chatbot for something that is not a gym, for instance, maybe you are building a chatbot for a hospital, or you are building a chatbot for a school, you just have to change this prefix. And your prefix could be shorter than mine actually, and maybe a little bit longer, but not too long. So I'm just trying to tailor the prompt so that to give me exactly what I want. Okay, for instance, I added this last part that says if you don't need to tell them where you got the response from. I added it like that was the last thing I added. That was the last thing I added to this file, and that was because the chatbot kept saying, based on the information you provided me earlier, that was what it was giving as the response. So I don't want you to say based on the information you gave me earlier. That's too robotic. So I don't know, whatever makes your answers better for you, just add it there. Okay, so that's the prefix. Then we take the retrieve context. This is the context that we got from the database, and it comes as an array because it's going to give us like four chunks of text from the database that is kind of similar. Remember, it's doing a similarity search in the vector database. So four items that are similar to the user's question. That's the context. Then we have the chat history, and we have the question, which is the standalone question. So yeah, that is it. And we are expecting helpful answer from the generative AI model. Okay, that's it for the answer prompt. Up next, we want to initialize the model that we are going to be using. So like I said earlier, you can choose to use just only the GPT 3.5 model, or you can choose to use both, or even use only the GPT-4 model, depending on what you want. Just try them out and see the kind of responses you get. And also, based on your budget, you decide which you would use. For generating the standalone question, we are going to be using the older model, which is actually faster. And for generating the response or the answer for the user, we're going to be using the GPT-4 model. So if you want to use just one model, all you need to do is just call this model. And then everywhere you see faster model and slower model, just replace it with model. Then you define the question chain separately from the answer chain because they take two different arguments. This one here, the question chain takes the standalone question prompt, while the answer chain takes the answer prompt. Up next, we have a function that performs question answering. And before we come to that question, I'm going to show you guys what run conversation function is. And we'll also come back to what the chain is, how we are able to use the question chain and the answer chain to generate the main chain, like the chain that manages the entire chatbot architecture. So the chain that manages this entire stuff here. Okay. So let's talk about the run conversation function. Run conversation function is the function that is called when the user clicks on the submit button like we defined up here. So let's go back down. So most of what is happening in this run conversation function is happening on the DOM. It's actually like DOM manipulation on the browser. Okay, so the first thing is that you get the user input, which is the question that the user is asking, and you get the value. Once you're able to save it in a variable called question, you clear it by equating it to an empty string. Then we get the chatbot conversation container. That is just this area where the chatbot will show up. We'll soon see that come to life. Then we get the human message bubble, and we also get the AI message bubble. Okay guys, so I think it's time for us to do something. So let's see. Hello, my name is Mary. How do I register at your gym? So this is the user bubble, which is, what did we call it here? New human speech bubble. Okay, that is what is created. And then we have the chat bubble or the chatbot bubble. Okay, so we asked the question and the chatbot says there are 3 ways to sign up for a membership at our gym, blah 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 blah. Okay, so we got the answer, and the human speech bubble is filled in with the question from the user. Then we add the question to an input object. This is in JavaScript, this is just the same as writing question to be question. And we invoke the chat AI chain here. We wait for the results and we destructure whatever we get to get the result. Then the result, we attach it to the AI speech bubble. All right, guys, so that's it. Now let's go back to talk about what is going on here. What is going on here? What is chain.invoke? So I'm just going to come up here and let's see what chain is. So it says a runnable sequence is a sequence of runnables where the output of each is the input of the next. What is a runnable? So a runnable is like a function or an object. Remember, in JavaScript, everything is an object. So it's an entity that gives out that it's an entity that returns a response, that gives an output. Okay. So runnable sequence is a sequence of runnables, and the output of one runnable will be passed into the as the input of the next runnable. Why do we need this? First of all, we are trying to do some formatting here. We get the user question, which is input the question. Remember, we have input here, and input has a property called question. So that is what we will get up here in the chain. We get the user question. Then we also need the chat history, and we need to retrieve the context from the vector store. So these are the three things that we need. And if we come up here, for the standalone question, we'll need the chat history and the question only, just the two. But for the answer prompt, we need the question, the chat history, as well as the retrieve context, which we got from the vector store. So these three things are very necessary for us to define in our chain. And for us to define them, since we did not get them directly from this place, we're going to be generating them. So chat history is a function. In the function, we load the memory, this memory that we defined up here, this memory. So we load it. Remember, the memory is going to contain the chat history. Previous chat history is going to contain the question, current question, and current answer. Okay, so let's go back. Where were we? Yeah, so we load the memory, and then we check if there's chat history in the memory. This operation will return true or false. If there's chat history, if this is true, then we want to return the chat history. Otherwise, we just return null. And that will be it for chat history. For the retrieve context, we need to retrieve something from the vector store. So we are going to be calling the retriever which we imported up here. Where are you? Here is the retriever. Just going to open it on this side, and I'm going to close this sidebar. So we have the retriever, and I'm going to come down here. The retriever has a getRelevantDocuments method. Okay, so let's talk about the retriever on the right hand side here. Up here we have some libraries imported. We have Supabase vector store class, we have OpenAI Embeddings class, and we have the create client method. And we also have all our environment variables up here, and we are checking to be sure that they are defined. And we're creating OpenAI embeddings. What are we going to use OpenAI embeddings here? Then we'll create a Supabase client, and then we initialize Supabase vector store and pass in the parameters that we need to pass in. We need the embeddings, and we need an object containing the client, table name. Remember this table name when we're creating the database vector store, and the query name. This is the query that we'll use to run the similarity search. So once we get the vector store, we are going to call the #retriever method. And we're going to be exporting that from this file. Now going back here, we said retriever.getRelevantDocument. Actually, let's see what this, if you hover over this, we can't really see anything. This is JavaScript, so let's just copy retriever.getRelevantDocument, come back here where we have the retriever originally defined, and we hover over getRelevantDocument. So it says main method used to retrieve relevant documents. It takes a query string and an optional configuration object and returns a promise that resolves to an array of document objects. So it takes the question, performs the search, and returns an array of similar documents. And that is it for retrieve context. So by the time we get these three things that we need, we are going to be using them to perform question answering, which we define up here. So we are almost getting to the end. We get the question, retrieve context, chat history. Remember what we talked about for the runnable sequence. Whatever we get from the first element, we pass it into the next element. So those are the three things that we need. And this is just for demonstration purpose. We are going to see it in the console. We'll see the context that was generated, and then we'll see the chat history. Actually, I'm going to add a question. I'm going to add a question here. So this is divided into like 3 sections here. First, we generate the standalone question. Then we generate the answer, and then we save the chat history to memory. Now, back to generating the standalone question. First of all, we check if there's a chat history. Remember that for the first question the user asks, there's no chat history at this point. So if there's a chat history, we serialize the chat history. Okay, just connect from here, bring it to the right, close this back. So we edit the chat history and we say if the message type, so we take each message in the chat history and we say that if the message type is a human message, we want to return a string that has a string that is prefixed with human. And if it's AI message, we want to return a string that is prefixed with assistant. So that way we know which one is human and which one is the assistant, which is our chat bot. And once we get all that in an array, remember map function returns an array, then we join them to get one string, and we separate each item in the array with a new line. And then so once we get the string, that is what we are going to be returning as chat history string. So closing this again. And if there is no chat history, we just set it as null. Then we call the question chain. Remember that the question chain is defined up here, and we are using ChatGPT 3.5 Turbo. And we have the LLM, the model itself, and the standalone question prompt from up here. Okay, let's go back. So this will take the chat history and the question and perform its magic and return a standalone question. It will return a result that contains a test. And that test is the standalone question. So that's what we define here, standalone question equal to test. And we're going to be printing it, so we see what standalone question is. The second step, to generate the answer. So first of all, we already have the retrieved context, which we got from here, remember, from the first part of the runnable sequence. This is the retrieved context. Okay, so back up here. So the retrieve context, we want to format it as a string. Remember, it's going to be returning an array of different chunks of text that we got from the vector store. So we format it as a string. And that method is defined up here as given a list of documents. This util formats their contents into a string separated by new lines. So it does something similar to what we defined for the serialized chat history function actually. But this time around, we don't have the human message and the AI message specification. Anyway, so we have the serialized context and we add it here to the answer chain. Then we add it here to the answer chain and invoke it. We also have the chat history, remember. If there's no chat history, we just put an empty string. That's the same thing we have here. So this double question mark just says if what is on the right hand is null, use what is on the left hand. Okay, chat history, retrieved context, and the standalone question. So we use this. This is where OpenAI LLM is going to do a generative operation. So it's going to generate a response. Okay. Now the next step is to save the chat to memory. So we have the original question and we have the generated answer here. So remember that when we defined the memory, just going to go up here. When we define the memory, we have the input to be the question and we have the output to be the test. Okay, let's go back here. Remember, we're still working on perform question answering function. So the last thing last line of code in the function is a return statement where we're returning an object that contains result, which is the answer, and sourced document, which is a retrieved context, just in case we need this for anything. But I don't think we actually need it. Whatever we return here, that is what we are going to be using in line 131. And guys, that is it. So let's go back to the browser and see what we have on the console, what we have printed on the console. Just going to open inspect element and click on console. Make this smaller a bit. Okay, so we're gonna start testing. Let's see. Hello. Okay, so we have here, so this is the first thing that we printed. It contains the chat history question and retrieve context. Let me show you guys up here again. In the perform question answering function, what we have in line 66. So chat history is null because this is the first message. Then question is, hello, my name is Mary, blah, blah, blah. Then the retrieve context, it retrieved 4 documents. You can actually specify how many documents you want to retrieve. But here we just have 4, which is the default amount of documents. And the first thing that was retrieved, we have the page content, which says, getting started, do I need to be a member, blah, 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 blah. There are 3 ways to sign up. I think this is actually where the answer was gotten from. There are other things here. Let's see what we have here. What if I'm new to exercise? Yeah, this is relevant. I think it's relevant because this person is saying, how do I register at your gym? Okay. So apart from the person being a new subscriber, it could also mean that the person is new to exercise. Then we have the second one. Yeah, these are questions that a new member would want to get answer for. Can I train with a friend or a group? Yeah, quite similar. But you can see that the most similar answer, or what the chat AI was able to generate, was from this first, which actually has all the information that we need. Okay, that's it for the first thing we printed. What of the next thing we printed? Is standalone question. Standalone question, how can someone register at your gym? So this standalone question is the question that was formatted from the information that the user gave. So the user says, hello, my name is Mary, how do I register at your gym? And with the prompt, the standalone question prompt, which this is the standalone question prompt. So the standalone question prompt plus the chat history, which at this point is null, plus the user question generated the standalone question. Okay, let's continue with our chats. What else? I'm going to ask about water. Do you have drinking water? Yes, there's water at the water fountain free of charge. Okay, let's go back to the console. So we have chat history now. Oh, look at that. So the chat history has human message. Remember we specified that in the where is that function? Serialized chat history. So we have human message and the AI assistant message. So the human message is, hello, my name is, the specific, not the standalone question now, the specific question that the user asked. And that is the first one. Then the second one is the AI message. And the third one is the new human message. Do you have drinking water? The fourth one is the AI message that was just generated. Yes, there's water at the water fountain. Okay, that's it for the chat history. Then the question is the exact question, not the standalone question. Do you have drinking water? And the retrieve context, let's see what the retrieve context contains. Do you offer locker rooms with showers? Oh, so I believe this showers here is just because of the water. Okay. By the way, I feel like these chunks are too large. You can reduce the chunk size by changing that parameter in the split document function. Let's go back to split document. Where are you? This chunk size. So this first element in the context is talking about showers. Let's see the next one. Okay, open this. The next one, we ask members to refrain from bringing outside food and drinks. Drinks, again, that's water. We offer the selection of blah, 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 blah. And the third one, let's see. What is your dress code? We require proper workout attire that is clean, blah, 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 blah. Do you have a lost and found? And what is your policy on food and drinks? So because of drinks, okay. Then the last one, what if I'm new to exercise? Do I need to bring my own workout clothes? What are your gym hours? I don't want to read everything, but there's probably something about drinking water in this, or maybe you just picked it up because it has to get 4 matching chunks. Okay, that's it for the retrieve contest. What else do we have? Then we have the new standalone question. Do you offer drinking water at your gym? That's an interesting standalone question, guys. All right, so let's run one more. I have 7 children actually. Unfortunately, we do not offer on-site childcare services at this time, so don't bring your children. All right, guys, so let's see what happens when we ask a question that we have nothing about it in the knowledge base, and I think that's the parking space. Yeah, so we don't have any information about parking space, so let's just ask. So the standalone question is there parking available at your gym? It says, I'm sorry, I don't know the answer to that. Please email awesomegym@sample.com for further assistance. Okay, guys, so it's time to test the memory implementation that we did for this chatbot. So we're going to try and ask it about something that is not in the vector store, but is in our chat history, our conversation history. How many kids do I have? What is my name? Your name is Mary. Okay, it's able to get this one. So the thing is, the problem is coming from the standalone question. Okay. Anyway, I noticed that sometimes when you give it a statement, something that is not a question, like for example, you just say, hello, my name is Mary. The chatbot will say something like, I don't know the answer to that question. Please email blah, 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 blah. Of course, my name is Mary is not a question. I'm just introducing myself. So you can fine tune this chatbot to be able to know when there's just a statement, like it's just a statement, just an information, not a question, and be able to decide what to do in that situation. So that is your homework. Feel free to practice this, build a project by yourself. The task I just gave you will help you to build something that you can say that you actually worked on by yourself. So I encourage you to do that. Let me know in the comment section how that went.